Here we go, folks. So today we're going to talk about 1D barcodes. Can somebody give me an example of where you've seen a 1D barcode?
Right there.
Yep. Your drink that you're drinking out of right now likely has a 1D barcode on it.
What about this one?
That has a barcode on it as well.
Is it 1D?
It is 1D.
I got a QR code.
What's the difference between a 1D and a 2D barcode?
What's two dimensions? How many wheels?
So 1D, I can read using just one line in one direction, right? So when I look at this UPC code that's on the screen here, I'm going to try to real quick get my pen working here if I can. Let me see. Yeah, I know. I got to get a color though too. Pointer options, ink color. Love how it defaults to white, like that's a color I'd ever want. So when I look at this 1D barcode, the reason why it's one dimension is I can read across it in one line this way, and I'll be able to read it. Now QR codes, data matrix codes, you'll see some barcodes that'll look like this. They'll have like a box, and they'll have little shaded regions like this all over the place. QR codes are a good example of that. They might even have a little target in them that shows a bunch of codes and stuff like that. As soon as you see that box, I would have to read in both the X and the Y direction if I was going to read this QR code or this data matrix code. But your UPC symbols, your code 39 codes, all of those types of barcodes can be read in one dimension. So all I got to do is run a single scan across it, and that thing doesn't change in the vertical direction. It's the same in the vertical direction. It only changes widths of bars in the X direction. So what are these for? Well, what they're designed to do is they're designed to be easily read by machines. So whether it's a machine vision system, a fixed scanner, or a handheld scanner, 1D barcodes are the most common thing that you're going to see out there. So many times if you're manufacturing a part, one of the things that you'll do on that part nowadays is actually put a barcode right on it, so that somebody could scan it, they could get more information. Nowadays you might even see QR codes and data matrix codes on brochures, and I can scan them with my phone, take me right to the website, I can sign up, I can get a data sheet, I can get whatever I want. Go ahead, Dalton.
You said one-dimensional barcode. Is there actually 2- and 3-dimensional ones, or what?
2-dimensional barcodes are very common. QR codes, like when I look at my Diet Coke bottle right now, there's a UPC symbol on here, and the folks that are watching this later on can't see it, but then there's a QR code on here as well. And the QR code, or something you might see like a UPS code, things like that, we'll talk about those, but they change in both the X and the Y direction. So they're a little bit different look than what a 1D barcode would look like. 1D barcode's always going to be these lines in the vertical direction. That's what you're always going to be looking at. Whether it's UPC, code 39, doesn't make a difference. The easiest one to learn, and one of the most common barcodes that's out there still today, is the code 39 barcode. It uses 9 bars to represent each symbol. Now the bars are both white and black in color. So don't think of bars as only being black. The space between the bars, the white space in between, are actually bars, but they are white bars. So there are black bars and there are white bars on a code 39 barcode. Wide bars are approximately 3 times wider than narrow bars. So if I look at this, I'm going to find my pen. Oh, it's on the other screen here. Oh, crud, it didn't give me my pen back. That kind of stinks. Oh, yeah, there it did. So as you look at this, that first one, is it wide or narrow? Narrow. So narrow will give you a 0. So if I look at the 2 types of bars that are here, I have black bars and I have white bars. So if you think of the bars being binary in nature, the narrow bars are 0 and the wide bars are 1s. So if I look at these black bars, what are the black bars in binary code?
0 and then 1 for the white.
No, just look at the blacks.
0, 0, 1, 1, 0.
0, 0, 1, 1, 0. That's the black bars. That's the way you got to think about the code 39. How about the white bars?
1.
1.
0, 0, 0.
Perfect. So you can see this one's definitely a 1, this one's definitely a 0, this one's definitely a 0, and this one's definitely a 0. So this is an easy one to deal with because we basically are just looking for wide and narrow bars. I'm going to pull up my eraser here real quick, if I can find it, just so I can erase that mess there. Go back to my pen.
So, are you going to tell us that all barcodes are just binary bits, and then it just reads it from left to right?
All barcodes have a binary component to them. That is correct. The problem is when we get into data matrix, it's no longer bits anymore. Now we can have 16 bits. We can have a word. We can have a byte. So in the case of a 1D barcode, yes, we're looking at really just bits, especially when we're talking about a code 39 barcode. Now, one thing about a code 39 barcode is a code 39 barcode will always start with a star, then it'll have the data, whatever that data is, and then it'll have another star. So this symbol right here is the star symbol. 00110 1000. The black bars versus the white bars is a star symbol. So if I go to the next slide, what I will see is the star is right here. And it's 00110 1000. If we go back to where we were, 00110, that's this one, and 1000. That is the star. So the reason why I print out these slides for you is as we go through this is going to be much easier if you have the answer key. This is essentially, for your code 39, this is essentially your key. You need this to be able to decipher code 39. Now, the first thing on code 39 that I want you to notice, though, is what characters can be represented on code 39? A through Z, right? We can represent the whole alphabet, A through Z. We can represent the characters 0 through 9, the numeric characters. And we also get a couple of symbols. We get a dash, a dot, a space, an asterisk, a dollar sign, a slash, the addition sign or a plus, and a percent sign. So we get access to all of these characters. So let's go ahead and look at one of these. So if I ask you, what is this code? The first thing you're going to do again is you're going to decipher black and you're going to decipher white. So don't look at these numbers over here. This is giving it away, right? But let's decipher black first. What is this bar?
0.
So this one's a 0. How about this one? 1. 0. 1. So I'm going to write that down. 0, 1, 0, 1, 0. Somebody watching this later on is going to hate my penmanship with this goofy little tablet. And then the white bars, what do I have?
0.
0. 0, 0, 1, 0. 0, 0, 1, 0. So we should align with what this says over here. And now we go find it in the table. Now I just took a screenshot of the table to get you some of the things that are on here. The easiest way to do it is to try to maybe find, like when you look at the big table, it's easier to kind of find this area first. But if I go back to 0, 0, 1, 0,
It's the letter I.
yeah, so 0, 0, 1, 0 I can see puts me in this chunk of the code right here. 0, 0, 1, 0 to 0, 0, 1, 0. And, I don't know why my little mouse isn't coming up anymore.
Are you recording?
I am recording.
Hello, people. How are
Great.
you? Buy me Diet Coke.
So 0, 0, 1, 0, 1, 0 is going to give me this with the 0, 0, 1, 0. So you were right there, Ed. This is the letter I.
I got a question.
Yeah.
How much data can you store in a barcode? Or it doesn't not matter. You can just infinitely write a barcode.
Well, so this is so that's a great question, Ed Scott. Is he's like, well, I can just have an infinitely long barcode, and that could store an infinitely long piece of data. That would be true. However, you'd have to have an infinitely long box or an infinitely long label, right?
Yeah.
So like a UPC symbol, I think you're limited to 12 characters. Code 39 can go longer than that, but we typically don't go longer than about 12 characters just because we would have to have a really, really long barcode. We'd have to have a really, really long scanner. So this is the reason why 2D barcodes exist, right? Because 2D barcodes in the same amount of real estate, I can go in the X and the Y direction, and I can get a lot more code. So like your UPC on your Coke bottle or whatever, Like if it's a short UPC, it might be 6 digits, and for a longer UPC, it might have 2 halves and be 12 digits. Go ahead, Gavin.
So, like, how do they have the amount of variety that they do at stores when the barcodes are that short?
So the barcode we're looking at right now is code 39. That's not
I've
UPC.
seen those when I worked at Blends and Fireleys a lot.
You may see something like this. Well, you got to be careful though. Mostly what you're seeing if you're in a retail market like a grocery store or department store, you're seeing a UPC symbol. You're not typically seeing a code 39. Code 39 is kind of a base barcode. A UPC symbol is a little bit more of an advanced barcode. And I'll show you that in a little bit. I get a little bit more depth and I get more characters and I get all these other things with the UPC code. Go ahead, Dalton.
With the test, how much of data are we going to have to remember? Like how much combination?
I'm going to give you on the test, I'm going to give you something like this. And then I'm going to give you a bunch of code 39 barcodes to decode. And then I'm going to ask you a bunch of questions about it, right?
Say what you're going to give them for the audio people.
Well, yeah, so I'm going to well, they can see this, what I got up there right now. I'm recording the screen as well. So yeah, so you're going to get, this will be an example of what I'm going to give you on the test. So on the test, I would give you something like this, and I'd ask you to decode it. And so now what you got to do is, this is where scratch paper is going to come in really handy, right? You're not going to want to try to do this without scratch paper. So what I'm going to do is I'm going to start out on this one right here, and I want to decode the black and the white. So let's go on that first one right there. What do I get for the black codes? 0, 0, 1, 1, 0. And how about the white codes on that one?
1, 0, 0, 0.
So that's what I get. And now I'm going to go to the next one, which is right here. And I'm just going to kind of bounce around. I'll just do black and white again. Here's black. Here's white. What's the black on this one now?
0.
Oop, I lost my little thing. 0.
0, 1, 0. That's it.
0, 0, 1, 0, 1. Yeah, there's always got to be 5 blacks and 4 whites. And how about the whites?
You have 0, 0, 1, 0.
Perfect. And then I'm going to go to this one over here. I'll do black and white again. Blacks are?
1, 0, 0, 0, 1. You have 0, 0, 1, 0.
You can see how we're going a lot faster now. Now I'm on this one.
0, 1, 0, 1, 0. 0, 0, 1, 0. I feel like a robot.
I do too. And then black and white on this one here.
0.
Bender from Futurama.
You did it wrong. Oh, no.
0, 0, 0, 1, 1.
Yeah, I'm looking at the next one.
And then 0, 0, 1, 0.
Oh.
Now I'm going to go to this one up here. I'm going to go black and white. 0, 1, 0, 0, 1. And then 0, 0, 0, 1. You guys agree?
Mm-hmm.
And then this one in black and white is 1, 0, 1, 0, 0. And what's the whites?
0, 0, 1, 0.
Perfect. And I'm not going to decode this last one. Why don't I need to decode this last one?
It's going to be a star.
It always starts and stops with a star. So this one here is going to be a star. And this one here is going to be a star. So I don't need to decode the first and last, even though I did. Now I'm going to go look, and so again, I don't care about this one. If I went back and looked at the star real quick, I would see that the star is 0, 0, 1, 1, 0, and then 0, 0, 1, 1, 0, and then the 1, 0, 0, 0. I keep losing my crud. Got to get my pen up again here. Pointer options pen. There we go. So yeah, so this is obviously a star. Now, somebody give me the second digit, this digit right here. Look at your table.
Where? What D?
D. You have zeros. Yeah, that was the 0, 0, 1, 0, 1, 0, 0, 1, 0. How about the third digit?
A.
A? How about the fourth digit?
DDY.
No. D-A-I, I heard?
No, it's spelling your last name.
What's the fourth digit, Gavin?
L-E.
So we can go do a gut check on this real quick. I'll just do this one as an example. I'll make sure that the G is actually 00011, 0010. So I go back and I can see the G is 00011, 0010. That is definitely the G. And so that spells out Daigle, like you'd see there.
So that was an accident, I'm guessing?
Yeah, I use a random number generator, and it just spit that out.
Let's just
Barcode Generators.
So
Totally not screenshots.
Is your mind a random number?
completely random.
TJ, are you a robot?
I am a robot.
We take your face off and just like...
Yes.
Barcode Generator, obviously.
All right, the next one.
The Japanese.
So the next one, stay with me, folks. The next one here. What's the first and last character that we don't need to decode? Where's my mouse? So this one here is a star. So I don't need to code the star there. And I also don't need to code the star. I cannot find my mouse.
On the test, will we get the chart? Yeah.
Yes. Yeah, I expect you to memorize the chart, Gavin.
Just kidding.
I'll need $30 in 2
No.
hours.
$30 in 2 hours. I would take that challenge. I would take that challenge if you want to give that a whirl. All right, so the first one here, let's decode the blacks and the whites on the first one up here. So let's do the black and the white. So what's this first one here? 1.
1. 0, 0, 0, 1.
And then the whites? 0, 0, 1, 0, right? And then the next one?
0, 1, 0, 1, 0.
I agree. And then 0, 0, 0, 1?
Yep.
And the third, or I guess it's actually, so this one was this one. This one's that one. And this one's going to be this one now.
Yep.
1, 0, 0,
1, 0.
1, 0, then 0, 0, 0, 1.
Yep.
And then finally over here for the black and the white.
1, 0,
1,
1, 0.
0, 1, 0, 0. 0, 0, 0, 1. So I'm going to go back to my chart. I'm going to look for that 0, 0, 1, 0 first. So I kind of look here and I look for the 0, 0, 1, 0. And that's kind of this portion of the chart. And I see that the A is the 1, 0, 0, 0, 1. So that's going to be A.
A.
What's the second one here?
S.
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 The third one?
R-O.
Yeah.
R.
Oh.
O.
Whoa.
I guessed it.
I know that one, but I get AIDS.
Yep.
Next one's easy also. ELTT. Yeah.
All right, so let's go to the next one here. So I've got some folks that have already decoded this one. You said this is an E. This is an E-L.
Oh, BLTT.
T and T. So E, L. Don't forget, what does it always start and stop with, though?
Star.
So really, it should be star, E-L-T-T, star.
It's not our fault you didn't put the space.
I didn't put the space there. Now, here's something kind of cool. There are a bunch of barcode generators out there. And using something as simple as you can buy fancy, like little barcode handheld printers. They look like little label makers is all they are, and you can type in code, and you can say, I want, this version of code. You can even, for that matter, print it out on an inkjet or a laser printer and print it out to some sticky back paper, cut it, peel it, and stick it, and now you actually can generate your own barcodes. So it's as simple as going into something like this. Let me show you what it looks like real quick.
Hey, EJ, this is on topic, but I actually did this for my movie streaming service because you can do a disc-to-digital service where you copy the barcode,
Sure.
and then when I copy the barcode onto like a free barcode service or whatever, then I scan the barcode through my phone, and then I only have to pay like $2 for a movie.
Nice, nice, nice. So when you go into here, when you go into like a barcode generator like this, I can pick what it is I want to generate. You'll notice there are a ton of barcode styles out there. All of these barcodes have patents on them, many of which have long since ran out. The whole idea of the barcode is you get information that can be read by a machine. That's a big deal for us. So like code 39, if I type in ASRO, as soon as I create barcode, I only typed in 4 digits, 4 characters, but it came out as 6 characters on my preview. Why? It always gives you a starting and an ending code. That way the computer can say, look, the code is in between those 2 stars. Some machine vision systems can actually read the barcode and read the code printed beneath it if it's printed with human readable text, and compare the 2. So the common machine vision codes nowadays, or machine vision systems nowadays, are much more complex than just reading a barcode. But I can see how that ASRO code shows up. What we were talking about earlier, I think Dalton or Ed mentioned, well, you could have an infinitely long code, right? The problem is the longer I make this code, the longer that code becomes. So if I type in, ASRO is really cool or something, now I generate that barcode, what you're going to see is that barcode gets extremely long, right? And my preview gets small, but I can look at it, as a big barcode. Or, I guess in my preview I can't, but I can download it and print it out big. But now this may be longer than the label. If anybody's ever used the automated postage system at like the Postal Service, one of the things they ask you when you use it is they ask you to weigh your box, they ask you to measure your box, and then they ask you, the reason why they're asking you to measure the box is they want to see if the pre-printed label that they're going to give you is actually going to fit on your box. And if it's not, they're going to give you a different label. And in some cases, what we can do, like ASRO is really cool, I just typed in, right? I could put this onto a QR code, and I can put something like that in there, and I'm going to come up with something like that. Now, instead of this being a 1D barcode that maybe is 1 inch tall or a ½ inch tall, but 4 inches long, this QR code could just be 1 inch by 1 inch square. So I get a lot more data in this than I would the other ways. Go ahead, Matt.
Could you type Star Wars onto there?
Yeah.
I want to see what it looks like.
Yeah.
So are you limited to the length of a barcode, not because of what you can print?
Ooh.
I see Darth Vader's face.
Yeah. So
Sorry.
Some codes are limited based upon the style. Like the UPC, the short UPC, I'm limited to a start character, a finish character, and the 6 characters between. The long UPC, I'm limited to 12 characters. So some are limited by the format of the barcode. Code 39 can get really long. I don't know how long it can get, but the code 39 is going to be limited by how long I can print and put it on a package.
Well, I was going to say, is it not only limited to how long you can print and put it on a package, but how long or how big of a scanner you actually have?
Well, that's another thing too, because your scanner has to be able to read it.
Yeah.
And so you might say, well, yeah, it's a foot-long barcode. I'll just move my scanner further away. But the scanner has to be able to detect a change in line pair. It has to be able to check to detect black to white to black again. And if it can't see that because you move it too far away, it'll become kind of a blur and it'll all look like a black line, if you get too far away. So you're right. Your scanner plays a role in that as well. Absolutely.
So thinking you can have like an infinitely long one.
Sure.
Barcode, but I don't think you can scan it in sections.
So here's the question I have for you guys, though. So you guys hopefully can tell the difference between this is a 2D barcode because it goes in the X and Y direction, and we'll talk about this code later on. And this is a 1D barcode because I only have one direction, right? So if I type in Star Wars here and generate the code, then it just comes out as a 1D barcode. Only lines up and down. That's all I get. All right, so let's take a look at another one now. Hopefully this shows up on the screen. So I'll let you guys start decoding that. I'm gonna go ahead and you know what I did here? I kind of did it a little different. I called it spaces and bars. Really, I'm talking about black and white is what I'm talking about. So the bars are really the black lines. Ooh, I gotta get my color. I wish it wouldn't default to that weird color there. Ink color, red. There we go. So the black is really my bars, and the white is really my spaces. I call it black and white. I don't like bars and spaces, but I see it called both things. Now this code 39, I don't have to worry about this one because it's a star, and this last one is a star as well. So the first one here, my bars are 00101. My spaces are 0010. Somebody else look these up while I do them.
I'm doing these. Stop.
Okay. 010110. And the spaces are 0010. And the fourth symbol, now I'm over to here. This is my fourth symbol. 10. The spaces are 0010. And the fifth one will be right here. So this was number 2, this is number 3, this is number 4, number 5 I'm on. Sometimes it's just keeping organized. When you're taking the test, this is one of those things where you really got to try to stay organized. 00110 and 0001. The sixth one, I guess that's as far as I'm taking it. 11000. And the spaces are 0010. All right, so I think I have them right. Did anybody look this one up yet?
Is there supposed to be more?
Yeah, I didn't. I guess I didn't go out as far as I could have. This is 7, 8, 9. It might. I guess it doesn't on the next slide, but I only went out to the 2nd, 3rd, 4th, 5th, and 6th places. So I'll scroll back. I'll go. Excuse me. What'd you guys get for that second symbol? Nobody knows.
I'm looking at
$8 sign something.
what is it?
0010.
Yeah, I got $1.
D. Yeah, it's D.
Is it D?
Yeah.
I hope it's not Daigle again.
Oh, yeah,
It's
the
diagonal.
DI.
And then this one here is 01010. 01.
EJ
You got
diagonal.
DI.
Is it DI? You have 0101. Yep.
A-G-L-E. Wait, it's not enough.
So DI, and then what'd you get for the fourth one?
E. One zero one 10 E.
Is it E?
Yeah.
Is it die? That seems kind of strange.
You good, EJ?
Yeah, I got a frog in my throat.
Oh, it's
What are those, they call those things that can summon a ghost? The Ouija board?
What's the fifth one?
G?
J.
Yeah.
What is it?
J.
Is it J?
Yeah. 00110.
It's
That's
T.
J.
T.
It's T.
How's that G?
T.
T.
Is it T?
Under the 0001 for the space.
EJ, it's giving you a message.
Oh, you know what it is?
01, yeah. Oops. Alright, cool.
I bet you it's, is this one C? 11,000 0010?
Is that Diet Coke?
Diet Coke.
Yeah. C is.
I just thought I was trying to give you a subliminal message.
That's it. I think you guys are right. I think it would be if you spelled out the whole thing. I think you'd find out it's Diet Coke if you want to spell out the whole thing, but I'm not going to do that.
Let's just stop at Diet.
Diet C. Diet C. All right. Make sense?
Yes, sir.
All right. You just got good at code 39. I have a feeling anybody in here, if I gave you the code 39 matrix, the key, I think anybody in here could solve that barcode.
Do we wear leather while doing this?
Now, fortunately, you're probably never going to have to do that in real life, but there are a lot of applications of barcodes that extend beyond barcodes. You know, we think of barcodes labeling, products, or we can even like laser etch them into products and things like that, like machine parts and stuff and things. But even the idea behind like a motor encoder. Motor encoder is able to read like the direction and the speed of a motor shaft turning. That even still is similar to a barcode. I'm getting pulses. And if I count the number of pulses and I divide it by time, 10, 10, 10, 10, 10, and if I have so many pulses in a second, I could calculate RPMs. But even the length of pulses and the overlap of pulses and the direction of pulses, I can also determine direction or location on a shaft. So this idea of binary coded data like this is really, really handy for just a number of different reasons. All right, now, UPCA, the most widely used barcode system in the United States and Canada, and I'd say at this point, getting to the point where it's almost all over the world. It's used primarily as a way of identifying retail product by name and price for inventory and sale purposes. So all I need to know is what this code is on my Diet Coke, and I can overcome this. What you'll see is it consists of a unique sequence of numbers and barcode representing these numbers. So if we look at the way this looks, and everybody's seen one before, you can see it right down here. This is a UPCA code. So if you go to the grocery store, you go to Walmart, you go to Target, whatever, you're going to see this code. And as I look around the room, my Diet Coke has it on it. The Simple Green bottle over there has it on it. I wouldn't surprise me if these Expo markers, they don't, but I'm sure the box that they came in would have had a UPCA code on them. So as we drill into this a little bit more in detail, a complete UPCA includes 95 modules, 84 modules for the digits left and right, combined with 11 modules for the start, middle, and end. This part's a little bit tricky. So what you want to look at on this is you'll notice the start. You guys can see the start. It's black, white, black. Those 3 bars. Black, white, black. That is always going to start out your UPC code. The ending code is always going to be black, white, black. That's going to be your ending code, black, white, black. Then there's a middle code in the middle that sets apart. It's a divider between the left digits and the right digits. And that's going to be white, black, white, black, white. It's going to be that chunk of code. The other thing that they do to make it easy to read as I look at my Diet Coke is I can see my start and end code bars are actually longer. So they're not the same length as my data. My data is a certain length. My start and ending and my middle codes are actually longer. So step 1, we'll notice that the longer sections of code are at the beginning, the middle, and the end. Now, but remember, the start code is actually only 3 bars. I'm going to get my little screen here. There's only 3 bars here, 5 bars here, and 3 bars here. So be careful, because some of the additional bars are longer as you look at this. So my start code is just the 3 bars. So my start is right here, these 3 bars. That's my start. My middle code was white, black, white, black, white. So that's these 5 bars right here. This is my middle. That goes from here to here, includes the white on either side. All right? Then my ending code is these 3 bars here, which is the black, the white, and the black. All right? So the longer section of the codes, when you look at the start, this sometimes screws people up. They want to start right here. This would be wrong. If you're trying to, your start actually starts right there. Right beyond that start code is where your start's going to start. Okay? Now here's where it gets tricky. When you look at the bars, I'm kind of zooming in on that left half right now. When I'm zooming in, I see my start code is right here. Let me write it on here. Here's my start. Those are the 3 bars of the start, and these are the 5 bars of the middle, right there. The 3 bars of the start and the 5 bars of the middle. There's actually 4 widths of a bar, whether it's a white or a black. There's 4 widths that we're dealing with. And so it's kind of tricky to see this, but you can see like this bar here, right here, is definitely a 1. That's the narrowest bar. Can you see that? The narrowest black bar, that's a 1. This bar right here is a 2. It's a little wider than the 1, so that's my 2. I don't see a 3 for a black bar, but I do see a 4 for a black bar. The 4 is much wider yet. So you can kind of get the variance of how wide these bars are. Now this is hard for a human to read, right? But as a scanner, I'm running a beam of light and bouncing it off of this. The beauty of black and white is, what does it do to light when it hits it? Black absorbs it and white reflects it, right? So this is the reason why the barcode works so great, is because as I flash light onto it, the black is going to get absorbed, the white's going to get reflected, and what gets reflected back to me is kind of the reverse image of the barcode, right? Go ahead, Dalton.
So when we get tests on this, is there going to be a way to measure like a difference between 2 and 3, or are we
Nope.
have to go out to eyeball it?
No, here's the beauty though. The beauty of this is they pre-built in some kind of error proofing to this. So like what they won't do is they won't have a code that's like, you know, like 2341 or something. They'll try to stay away from codes that, and if it doesn't match up to a code that you recognize, then you know that you read it wrong. You know what I mean? You'll see what I mean in a minute here. So each of these sequences of 4 digits, each of these sequences of 4 digits represents a character. So if I said, okay, this was a 2, this was a 2, this was a 2, and this was a 1, that's 2211. Then I go to that next white, 2, 1, 2, 2. That's 2, 1, 2, 2. Then I go to the next one. I can see it's 1, 4, 1, 1. I can see it's 1, 4, 1, 1. So I can see these sequences of codes. They're 2, 2, 2, 1, 2, 1, 2, 2, 1, 4, 1, 1. Each of these sequences of 4 codes, 1, 1, 3, 2, 1, 2, 3, 1. I'm having trouble with my pen there. But you get an idea of how those are grouped together. It's all sequence of 4 digits. So notice how the bars have 4 different values. The numbers 1 for 4 describe the width of each bar. We're talking white and black bars. So now what we do is we decode these bars, right? This first digit is 2, 2, 2, 1. This next digit, which starts here, is 2, 1, 2, 2. This next digit is 1, 4, 1, 1. I got to make sure I'm counting all of them, the whites and the blacks, right? The next digit is 1, 1, 3, 2. I want to make sure I don't lose my space as well. The next digit, I was ended on the 2, so I'm going to be on the 1, 1, 2, 3, 1. The next digit is 1, 1, 1, 4. And why don't I count these digits over here?
That's the middle.
That's the middle. This was the start. The on, off, on was the start. And that was the middle over there. So I can see my numbers. 2, 2, 2, 1. 2, 1, 2, 2. 1, 4, 1, 1. 1, 1, 3, 2. 1, 2, 3, 1. 1, 1, 1, 4. Pain in the butt, isn't it?
Yeah, I got it, yeah.
There's your deciphering code. Just like we had for the code 39, UPC also has a key that we can use. What you'll notice is it's not like they don't use all the same thing. There isn't like a 1111. What they've done is they've optimized it for error checking. So a lot of times that difference between the 2 and the 3 might be problematic. So a lot of times they'll set it up in such a way that they don't have a lot of 2 to 3 transitions. But they don't have a lot of 1 to 2 transitions, or whatever the case may be. This is the part I would give you on the exam. I'd have to give this to you on the exam, and then what you would do is you decipher it. So I would go to this thing here, and I'd say, okay, 2221. That was my first code. 2221 is a 1. Go to the next one. 2122. 2122 is a 2. Go to the next one. 1411. 1411 is a 3. The next one, 1132. 1132 is a 4. 1231. 1231 is a 5. And so on and so forth. There's a 6. There's a 7. There's an 8. There's a 9. There's a 1. There's a 0. There's a 4. Now, what if you were doing this and the number you came out with was 1412? What would you do?
Check again.
Yeah, you would check again. You obviously made a mistake. It could very likely be that you actually saw a 3. Is it really a 1411? Or it could be that maybe you're seeing a 7, 1312. This is what you'll find, is that you'll make mistakes and you'll read the barcode wrong, but 95% of the time this key will catch it. It's been optimized to try to catch those sequences. Go ahead, Matt.
So UPC-8, it goes by 4.
By 4 digits at a crack. But you have to get past that starting code. This is that other part, right?
I get this. I get getting past the starting point. I'm
Yep.
just saying, like, after that, and the middle, and the end,
Yep.
it goes by 4s.
Yep.
And it'll say, hey, and like 2221 would be like,
It would be a 1. Yep.
okay.
Yep. Exactly
That's
right.
where I was getting confused.
Exactly right. So here's the deal. So that part usually people pick up on. It's just tedious, right? It's just tedious. Then there's a final digit. And I like to do this. This is a cool bar trick. If you go to the bar, you're with your friends or whatever, you're sitting around the bonfire, somebody's drinking a root beer, and they got their soda can. I love to do this as kind of a fun trick. I tell them, I say, tell me what the first digits are on your barcode, but don't tell me the last digit. Tell me all the digits. So they'll look at the barcode on their soda or whatever, right? And they'll read you all of these digits, but they won't give you that digit. So they say, okay, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1. And then you'll spit out, okay, the last digit's 2. How'd you do that? The last digit, digit number 12, is actually what we call a checksum. Anybody familiar with the idea of a checksum?
I've heard of it before.
Yeah, so checksum is a way to verify that the data we got is what we expected it to be. It's not some sort of superfluous data. If that checksum didn't match, the barcode would be invalid. These exist on your credit card. These exist on, obviously on barcodes. They exist all over. Even when you do like secure transactions over the internet. When we talk about sending secure data over the internet, that's all kind of locked and unlocked with some sort of key, which is kind of like a checksum. You know, a lot of times it's using things like modular math and things, stuff that you guys have studied in here a little bit. This is the process to come up with the checksum. All right? So add the odd placed numbers, multiply the odd numbers by 3, add the even placed numbers, add the results of 2 and 3, take the next higher multiple of 10, subtract 4, and then come up with the numbers. So the odd numbers here, when you look at the odd numbers, they're not talking about the numbers that are odd numbers. They're talking about the odd position numbers. So the first, the third, the fifth, the seventh, and so on and so forth.
For every other space.
Yeah, so basically as I look at these numbers, I'm going to add the 1, the 3, the 5, the 7, the 9, the 1. I'm going to add those up, and I'm going to get a number of 26, right? And then I'm going to take 26, I'm going to multiply it by 3, I get 78. Then I'm going to come back in, and I want to add the even numbers. So I'm going to erase these real quick. Go back to my pen. Pointer, pen. Now the even numbers are going to be the 2, the 4, the 2, the 4, the 6, the 8, and the 0. So 2 plus 4 plus 6 plus 8 plus 0 gives me 20. Then I add the results of step 2 and 3. So 78 plus 20 gives me 98. Then I take the next higher multiple of 10. What's the next higher multiple of 10? 100. And then I'm going to subtract what I had in step 4, which was 98. 100 minus 98 gives me 2. That's where that number 2 comes from right there. So if you ever want to look at that checksum and figure out what that checksum is, you can do that by following that procedure. So kind of funky, but all of that, when they print the barcode, right, when you generate that barcode or you generate a UPCA code on that website that I just showed you, it's going to generate that digit automatically. So it's going to go through the algorithm and generate it using the UPCA algorithm.
You would do this as a bar trick?
Sometimes. Is it kind of cool? Yeah, it is a lot of math to do in your head. That
I can see you whipping out a calculator.
yeah, I used to be able to do it. I haven't been able to do it in a long time.
I can barely do that shit sober. How is
Well, I would agree with that. So here's our UPCA demo. Let's try to work through a couple of these and see. So this one is in your notes right now. It's in your sheet. Let's try to do this one. So the first thing I've got to do is I first got to know where I don't use, right? I don't use these 3. Why?
Start, middle, end.
Yeah, these 3 don't count, right? I wish that wouldn't do that.
Oh, I thought you were going to underline all 3.
Yeah, I don't want to use these 3 because that's the start, and I don't want to use these 5, which include here to here, because that's the middle. So this is the start. That's the middle, and then the end are these 3 over here, right? Everything to the right of that line. And I could probably make this a little better if I just made this, pointer options. Let me go back to my eraser for a second. All I got to do is just show that it's to the left of that. So anything to the left of that, I don't want to use.
Yeah, it feels like you would be fun at parties, EJ.
Don't you think?
Yeah, describing the math behind Flip Cup.
There we go. There you go.
The TOF timers all over again.
That's it. So here's the deal, though. This is where it's going to get tricky now. We got to try this. What do you suppose this first white region is?
That is a 2. 4.
Well, I don't know if it's a 2 because, see, this is a 1, isn't it?
Where?
I'm seeing the 3.
That's a 1 right there, isn't it?
Oh, yeah. Where are we?
And that's a 2, isn't it?
So that's a 3.
This is a 3.
Then it's a 2.
2.
1.
1.
1.
Yes.
That's what I'm trying to figure out.
3, 2, 1, 1. Do you see it?
Yeah.
3, 2, 1, 1.
Now, what my next available space is this white space here, right?
Yeah, which is also 1.
1.
You let a skater do it for us.
1. 4.
Guys, you sit there.
That has to be a 4.
Does it have to be a 4?
Yeah.
Big. Yeah, it's huge.
Fat.
It's bigger than the white.
Is there a 4 that's available to us?
It's bigger
Yeah,
than
there
the
is.
white.
So here's another trick that I can look at, right? Is there such thing as a 1, 1, 1, 3?
Nope.
Nope. So Ed was right. That is definitely a 1, 1, 1, 4.
Bingo.
That's a 2.
This is a 2.
That's another 2. That's another 2. A 1.
That takes me to here, right?
Yeah.
How about this one?
Wait, how do we know that's a 2 and not
Look, you skipped some.
You skipped something, you compare it to the 1.
No, he didn't. He wrote it at the bottom.
Oh, he wrote it down bigger than
Yeah.
He just wrote it lower.
1 and still smaller than 3.
Yep. Let me go to my eraser real quick because I got an extra digit I want to show here. Kind of painful, isn't it?
Yeah. Yeah.
So this is 2, 1, 2. What's this one?
2, 2, 1, 2, 1, 3, 1, 1, 4.
1, 1, 1, 4.
Yeah.
Oh, that.
That's a 9.
Yeah. When I start writing that small, actually my little tablet has trouble recognizing. I gotta erase that real quick. Go back to my pen. Pointer options pen. That was a 4, right?
Yeah.
So let's just go do a quick check real quick and make sure that what we have even makes sense.
Jesus.
So 3, 2,
I can
3, 2, 1, 1 is a 0. 3, 2, 1, 1 is a 0. 1, 1, 1, 4. 1, 1, 1, 4 is a 6. 2, 2, 2, 1 is a 1. 2, 2, 2, 1 is a 1. 2122 is a 2. 1213 1213 is an 8. What did I do?
You show us the answer.
Oh, did I?
Yeah. Very
Oh.
briefly.
1114 is a 6. Then there's the middle. Then we go over here. What do we think here?
That is
Oh, that's not a 2, is it?
no.
3, 1.
You skipped the first one, I think.
Yeah, it's 1, 2.
Oh, crud!
It's 1, 3, 1, 2, 1.
I skipped the first one there. Yeah, this is where you got to be careful because remember that middle is the 5 bars, isn't it? So it's really easy to skip that first black bar there. So I go back to my pointer options pen. So what is it? It's 1,
Yeah, it's a 1, 3, 1, 2, 1.
1, 3, 1, 2, and then 1, 2,
That's a 3.
1, 2, 3, 1.
Yep. 1, 4. 1, 1, 3.
All right, I'm done with this crap. All right. So 1312, 1312 was
The human skin.
7. 1312 was a 7. 1231. 1231 was a 5. 1411. 1411 was a 3. And the number you get is 612-867-5309.
Ha ha ha.
Okay.
Ha 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 ha.
All right, question for John. Are you singing the song?
Okay, yeah.
Go ahead.
Why have a more complicated code with less possible digits?
So in this particular case, because what we're doing is we're using these as basically part numbers for products, all we have is numbers. All we have is numbers, and so the UPCA was identified for inventory, price check scan. So each one of these part numbers or UPCA codes would correspond to a product. So like, as I look at my Diet Coke, 0490450 would correspond to this ounce bottle of Diet Coke. And so now what I would tell you is you are correct. A lot of stuff now is also getting QR codes.
You're lucky that half was
QR codes are better because I can display more data, I can get more digits and all these other things. But this is kind of the best of the best at the time that we had. Colby.
2 questions. One, is it kind of like Diet Coke? They're like, this is our number, so the whole industry won't use that number for Diet Coke?
That is correct. If I were to type this UPC code into like my computer right now, it should bring up this is Diet Coke.
Okay.
Yep.
And then 2, other than picking up nerds at the bar, where is this applicable? Like, where are we going to want to know how to do this?
Yeah. So are you ever going to decode a barcode by hand ever again?
No.
Probably never. Probably never.
Pinch and you need a code.
However, are you going to ever be out in industry and be asked to install a fixed reader for a barcode on a conveying line?
no.
Are you ever going to? Yes, you will. Are you ever going to be asked to set up a machine vision system to read a barcode and need to understand the difference between code 39, data matrix, UPCA, and QR? Absolutely. That's the level at which you guys are going to use it. I've seen people install let's say a Cognex machine vision system, right? And they go to set it up and it's not working. And the only thing that they didn't do was change the setting where it said code 39 to say QR code. They didn't know the difference between a code 39 and a QR code. They didn't even know the difference between a 1D and a 2D barcode, that they were different, that they should even go into that menu.
We wouldn't like code it. It's just knowing that this is this format, so the machine has to have it in this format.
And you might also give recommendations too, where somebody might say, well, we want to use a barcode, but we want this barcode to take somebody to a website. And what's the website? Well, the website is www.granger.com/motor bearing 31264. which barcode would you select? Would you select a code 39?
No.
Why not?
Too damn long.
It's way too darn long. So, and we haven't even talked about a data matrix code. So you would tell whoever it is that you're working with, you say, look, I know that's got to be a 2D code. It can't be a 1D barcode. That's got to be a 2D code, either a data matrix or QR, one of the two. Yep. That's really, and that's kind of where the next slide is here. You know, fortunately for us, modern day machine vision systems, handheld scanners, fixed scanners, they make extremely short work of doing this. At some point this semester, I'm going to at least demo the Cognex stuff with you guys so you can get a little taste of machine vision, get an idea of what machine vision is capable of. But machine vision is capable of reading a barcode, but I can also buy, I think everybody's familiar with the little gun that they have at Walmart, right? Or the little scanner where you run your package over the top of it. It's very common to buy a fixed barcode sensor that mounts like a sensor on a line, meaning it just looks down at boxes coming down underneath it. As long as it can see that code, it's going to read it and it's going to register what it's doing. And that barcode could tell me to go to this zip code, or it could tell me to go into the red bin or the blue bin or the yellow bin. You know, it could tell me a lot of different things just by reading that code.
How is this loaded onto a machine? Like, say you were working somewhere and they had a new product and they wanted to populate a barcode for it. Is there machines to do that, or?
Yeah, so depending on the system that you're working with, like if you're working at like Walmart or something, all the product comes with the barcode on it, right? But if you wanted to create your own barcode or your own QR code, you can get a printer that'll print these out, and they become labels, and they can just be applied using a labeling machine. Or in some cases, if you're not producing a ton of parts, it could just be done, you know, manually. If you look at like, I'm thinking like the COVID vaccine right now, right? There's a QR code or a data matrix code on there that not only identifies, you know, what the product is, you know, it's a Pfizer vaccine, but it identifies the lot number, when it was produced, what line it came off of, you know, all kinds of data on that one code. Yeah, what type of microchip? It identifies all of that stuff, you know, on just that one little piece of code. So there's a real power to this.
And then does that, not to go too far down the rabbit hole, but does that, like, do you load that onto the machine, or like how does the machine know?
So the machine, if we're just talking about packaging, it probably doesn't. It's just going to get labeled onto the product, and the machine may take a picture of that barcode to make sure it's present and that it's there, and it may register it that X number of this code went out.
That's more like
deep end. But that's more like I've got this sample way down the line later on, or there's a recall. There's a recall, and I want to make sure that nobody gets injected with this sample. Well, what's the lot number? What's the code? You know, scan it, and you know, a lot of times, even when you're at the hospital, right? I don't know if you guys have seen this or not. You're at the hospital, you actually are wearing a little barcode on your wrist, and before they inject you with any medicine, what do? They scan the barcode. They scan the medicine. What does that prevent?
Double dosing.
Yeah, it prevents double dosing, but it also prevents you from walking into, you know, you're walking into Joe Anderson's room versus Gene Anderson's room, and they say, hey, Anderson needs, you know, 100 milligrams of whatever this medicine is. You go to scan Gene Anderson's barcode. It was really meant for Joe Anderson. Guess what?
It's going to tell you.
It's going to tell you. It's going to set off an alarm and say, ding, 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 ding. No, you got the wrong patient that you're trying to put the wrong medicine in. So there's a lot of the applications of this type of technology, including just binary coding of motors and shafts and motion and all that stuff. Huge. If you understand this type of technology, it's absolutely awesome. So, all right, I'm going to end the presentation. I'm going to post this super long video on the channel. Let me see if I can Alt-R.